All right, year 8. So we got another practical video for you today. This time what we're doing is we're investigating conduction. All right, so conduction of heat more specifically, and we're going to compare the conduction of heat of different metals. Okay, so the way we're going to do that is by using this funky piece of equipment called a conduction star. So basically, you can see here, we've got these few spikes coming out here. They're all made of different metals. And then we've got a piece of metal in the center connecting them all. Okay? So basically what we're going to do is with a Bunsen burner, we're going to heat up that piece of metal in the center. And then we're going to time how long it takes for the heat to travel via conduction from that piece of metal in the center out towards the ends of these different metal rods. Okay? So let me just tell you what the different metal rods are made of. We're going to start here and go anti-clockwise. We've got copper, stainless steel, aluminium, iron, and brass. So copper, stainless steel, aluminium, iron, and brass. So what you need to do is as soon as I start that Bunsen burner going, okay, you got to time how long it takes for the heat to travel from the center to the end of those different metal rods. Now you're asking, how will I know when the heat reaches the end of that metal rod? That's because you might be able to see them on the ends of each rod. We've actually got toothpicks, okay, so just ordinary wooden toothpicks, all right? And they're stuck to the end of the rods with a piece of paraffin wax or a blob of paraffin wax. So similar to candle wax, but a little bit softer. It actually looks a bit like earwax, okay? So as the heat travels from the center out to the end, once the heat travels to the end of that rod, it's going to melt that wax. Once that wax melts, becomes liquid, that toothpick won't be able to stand up anymore. It's going to topple over. So basically what you've got to do is time from when I turn on the Bunsen burner until that toothpick topples over. All right? Now we're going to do this once, and then we're going to repeat it again and find an average so we can see how reliable our data is. So I am going to light up my Bunsen burner. So as soon as you see the flame go on, you got to start timing and then wait until that last bit falls. Okay? So, all right, flame is on, start timing. There goes one. There's the first one. Second. Third. Oh, fourth one. So we're just waiting on that stainless steel to topple over. Or you can see it a bit on camera. There's actually some smoke coming from some of the ends of the rods. I think that's the wax starting to evaporate. So I hope this finishes soon because it's getting a bit stinky. That last one is holding on for dear life, isn't it? Oh. All right, stop it there. There's that last one. Finally, we got him. So I'm going to set this apparatus up again, and we're going to do a repeat. Okay, so just a reminder, going anti-clockwise, our metals are copper, stainless steel, aluminium, iron, and the final one is brass. All right, so we're back for round 2. You can see we've got the exact same setup, exact same metal, same toothpicks. Okay, full disclosure, this is a different conduction star, only because they get quite hot, so I had to use a fresh one. All right, but in theory, everything's exactly the same. Just make sure the Bunsen burner's in the same position. There we go. All right, so I'm gonna light them up, and like last time, start timing from when I turn the heating flame on until that very last toothpick topples, and it's most probably gonna be stainless steel again, all right? So, okay, let's go. Start timing. All right, so that's the last one finally done, okay? So now that we've got our data, make sure you've got it tabulated in a nice, neat, enclosed table, and then go on and answer the discussion questions.